Welcome to the class, my dear students. In today's lecture, I am going to explain the damping rule in Z transforms. In the previous lecture, I have explained you what is Z transformation, and there are several problems I have made you to understand how to apply the Z transformations. Now, this particular rule is called as the damping rule. This rule says that if the Z transform of un is u of z, suppose, then z of, whenever you multiply un, the term un, by a raised to n, suppose, then in the function u of z, you are going to replace z by az. That is what the rule explains us. Let us now look at a particular problem to understand this concept of the damping rule. So let us say find z of n, a to the power of n is there. Now, what do you say about this un now? In the place of un, you have n. That's what the understanding. So, in the place of un, there is n. So, what is your un? First of all, we write, and then we will enter into the original topic. Okay. So, now what we see is, let us see the solution. Let your un is equal to n, because understand that the damping rule is for any un multiplied by a power n. So, in the place of un, you have n. So, your job is to find out what is z of un. That is, what is z of n. And we have already a formula, a ready-made formula is there for n. What is z of n? It is z over z minus 1 the whole square, which we have already done it. And now what we do? We just replace this z of a power n into n as z of n is z over z minus 1 the whole square. And so what we write? Z of a power n times of n is just u of, this is u of z, right? In this u of z, we are replacing z by z by a. By z by a. That means what is the function here? Z by a by z by a minus 1 the whole square. You can even rewrite this as z by a means what? You can rewrite this as z by a over z minus a by a. That means z minus a the whole square by a square. So, when you reverse the fraction, so because there is a fraction in the denominator, we flip the fraction and write it as a square over z minus a the whole square. So, what it gives you? 1a gets cancelled. So, it is az by z minus a the whole square. So, this is what the formula, this is what the solution for z of n into a raised to n. So, in this damping rule, what you have to understand is what is un, first of all identify, because a power n combination will be there in the damping rule. So, whenever you have a power n combination with a function un, immediately it should strike in your brain that you have to use the damping rule. So, in the place of un, you have n, and so un is, what is z of un, you find out. In u of z, just replace z by a. That's it. So, very simple problem it is, right? So, let us now take another problem, try to understand this now. Z of, let us say, n into 3 to the power of n is there. Now, what we have to understand here, there is a combination of n and 3 power n. So, definitely we have to use the damping rule. By damping rule only, we are going to find out the solution. Now, here a power n means 3 power n. That is what. And then what is un? Un is equal to n. So, what is z of un? Z of un is given by z of n, and z of n is given by z over z minus 1 the whole square. And replace z by z by a. In the place of a, what you have? In the place of a, you have 3. Correct? So, this is what you are going to replace. So, what is the value now you get? Z is replaced by z by 3 by z by 3 minus 1 the whole square. you can rewrite this as z by 3 over z minus 3 over 3 the whole square. That means the whole square and the whole square. So when there is a fraction, again flip the fraction, that is 3 square over z minus 3 the whole square. So the solution will be now 1 3 gets cancelled. So it is 3z over z minus 3 the whole square. I hope you could understand. Just let us do one more problem quickly to make you to understand this function by using the damping rule. Z of n into e raised to an is there, let us say. E raised to an is there. So now let us, what is un here? Now again, un is equal to n, and in the place of a, what you have? E raised to n. Let us write for our, let us say some e power 2n is there, let us say. Now how can you rewrite this function as actually, it is z of n times of e raised to 2 the whole power n, right? So z of n into e raised to 2 the whole power n. So is it not in the understanding that the place of e square there is a. So this is what the application of damping rule. So what is un is n and a power n is e power 2 the whole power n. So what is in the place of a? You have a square. Okay. So now what is your z of a un? That is z of n. What is z of n again? Z by z minus 1 the whole square. So by using the damping rule, you can rewrite this as, z of n times of e square power n will be written as, this is your u of z, right? So u of z is z over z minus 1 the whole square. Your z is replaced by z by e power a. In the place of a, you have e square. I hope it's clear. So now this is what we have done. Now the place of a, you have a square. That's it. So this is what we have done. And so now what we write? Rewrite this as z by e square over z by e square minus 1 the whole square. So what you can rewrite this as z by e square whole divided by z minus e square by e square the whole square. Correct? So let us flip the fraction. Then you will get the result as z by e square times of e square the whole square by z minus e square the whole square. So the value is what now? Z times of e square by z minus e square the whole square. This is what the solution. I hope you are able to understand the damping rule application. Quickly one more one more problem I will give you. Try to understand that also. Z of, you wanted to find out n square times of, let us have 5 to the power of minus n is there. Now here you have to understand, again there is a power, a power n, the whole into n, some un is there. So you can rewrite this as z of n square into 5 to the power of minus 1 the whole power n, right? So what is in the place of a you have? In the place of a you have 5 power minus 1. In the place of un you have n square. So this is what the understanding. So now what you have to consider? You have to consider that un is equal to n square, and what is z of un? Z of un is given by z of n square, and that is given by z plus z square over z minus 1 the whole cube. This we have done already in the previous lecture. So now what we have to do? Z of, by damping rule, what is z of un into an? That is n square times of 5 power minus 1 the whole power n is given by u of z is z plus z square over z minus 1 the whole cube. You're replacing by z by 5 power minus 1. So is it not the same as z is replaced by z plus z square by z minus 1 the whole cube? Now z is replaced by, can I write 5 power minus 1 in the denominator can be written as 5 z, we can write like this, right? So just z is replaced by 5z, so 5z plus 5z the whole square by 5z minus 1 the whole cube. So this is the answer. I hope you are able to understand the damping rule very clearly. That's it. It's a very simple property where whenever you have the product with a power n with the function un, suppose, then immediately identify un, find u of z, replace z by az. That's it. And whatever, if you just learn this one, then you will understand when the power is minus, whatever. But remember this particular formula, it's very easy to do the problems. Don't get confused. Thank you.